Hello and welcome to part 9 of the LinuxKI video series. In this session, we'll be reviewing the Wait Event Analysis report, which gives us a global perspective on the various kernel functions and stack traces where the various tasks go to sleep. All of the reports produced in the KI-all script are listed here. So far, we have covered the KI ASCII file, the PID analysis report, the disk analysis report, the CPU and run queue analysis report, and finally the CPU profile report. The Wait Event Analysis report discussed today can be found in the .txt file beginning with KI wait. The Wait Event Analysis report is based on the sched switch events and provides information on which kernel functions and stack traces result in tasks going to sleep. Note that the kernel functions and the stack traces are only collected with the LinuxKI tracing module. The first section provides a global scheduling view. Since there are 16 CPU cores and 20 seconds of trace data, there is an aggregate total of 320 seconds of trace data analyzed. A sched switch can occur when the task goes to sleep, which is a voluntary sleep, or when a task is forced to give up the CPU to allow another task to run. This report will focus on the sleep or voluntary sched switch events. The second section provides a list of kernel functions that called switch to voluntarily go to sleep. The list is ordered by count. Many of the kernel functions listed are normal. For example, sleeps in IO schedule are normal for IO, and the average sleep time of 253 microseconds is excellent. And long sleeps in functions such as worker thread, poll schedule timeout, and many other functions are normal as well, as threads can sleep while waiting for something to do or waiting for a timeout to expire. In this list, you are looking for kernel functions that shouldn't spend too much time sleeping, such as mutex lock slow path. There were over 97,000 sleeps in mutex lock slow path, which resulted in over 90 seconds of sleep time, or an average of nearly 1 millisecond per sleep. The maximum sleep time was 757 milliseconds. You will also find kernel stack traces leading up to the sleep, which can help identify the code path causing issues. A single sleep function can have multiple stack traces. These stack traces provide us details about the code path leading up to the sleep. Note that it looks like most of the I/O is generated by doing direct write I/Os and direct read I/Os to an ext4 file system. There are 3 code paths leading up to the mutex lock slow path: one for LSeeks, one for writes, and one for reads. The Wait Event Analysis report also shows some of the top tasks that frequently go to sleep. Note that the IO8 tasks call the functions IO schedule and mutex lock slow path, which results in the task going to sleep. These tasks are likely competing with each other for the mutex. The PID analysis report can provide more details on each of these tasks. As always, refer to the LinuxKI wiki page for additional information and pointers to see other video series sessions. Thank you for watching and see you next time.